Hello friends, welcome you all to the next lecture of the JCE Connect series of online lectures. We will be starting today with the module 5 and the topic which we will be dealing is anchorage zone stresses in post tensioned members. So let us first start with understanding what is an anchorage zone, or it is also termed as end block. The zone between the end of the beam and the section from where only longitudinal stresses exist is referred to as anchorage zone or the end block. In these zones, the state of stress distribution is complex. The stresses are three-dimensional in nature. As the cables or wires are tensioned and anchored at the end faces, relatively large stresses develop over a small area near the end faces. These stresses, while changing progressively to continuous linear distribution, develop shear and transverse stresses. This can lead to a bursting force which can damage the end portion of the beam. So, let us start with the conceptual discussion. Now, I have defined here the anchorage zone or the end block as that area or that region where the stresses are uneven. Okay. So, the sentence here, the section from where only longitudinal stresses exist, that is, now if you see this figure, okay, you have a blue colored marked box, and when you observe the stresses inside this box, they are not linear, but when you see beyond this box, they become linear. So, the zone wherein the stresses are not linear, which exists from the face where your pre-stressing force is applied, is termed as your anchorage zone or the end block. Okay. So, now when we come to this figure, here I have tried to show it in the red color marking. Okay. What happens here is this area becomes a local zone or a concentrated zone wherein the pre-stressing forces exert a lot of stress which is three-dimensional in nature over this part. Okay. Further as they go, they become linear, which you observed in the besides figure, but this part becomes very much important with respect to the structural designing purpose. Okay. And this portion of the post tension beam is known as a anchorage zone or end block. So, if you are working on a site where post tensioning is going to happen, as a civil engineer, it will be your duty to check this anchorage zone or the end block, because if adequate reinforcement is not provided in this block, it will lead to bursting action, okay, which we will be studying the formulas and all the things which we will be studying in the further lectures, and it will cause a huge damage to the concrete in and around this region. So, what is an end block? It is an end block where your stress distribution is not regular, it is three-dimensional, and what happens is while the stresses transform to become linear, in that phase they induce the unnecessary tensile and the shear stresses. Okay. And we all know concrete is not good in tension. You can take a good amount of compression, but when tensile stresses are induced, it will lead to failure. So, one more important thing here to be observed is, see here the nature. Here the stresses are concave, here the stresses become convex. Okay. That is, the curvature is changing. What does this mean? The system is undergoing alternate tension and compression, okay, which is very dangerous. So, this part has to be taken care of properly while we are designing the pre-stressed concrete post tension members. So, in this series of lectures now, we will be studying how to design the particular reinforcement for anchor blocks, okay, or the end blocks, which is very important. So hope you have understood what is an anchorage zone or end block. In the previous paper itself, that is 2019-20 December paper, a question was asked, what is anchorage zone? Explain. Okay, so this figures along with the next slide explanation that you have to use. Again, the details are available directly in your code book, but directly if you copy paste from the code book, you will not get good number of marks. Okay, so understand what is this, and you can make your own proper notes. So these things now I discussed there with reference to the figure. Let's move to the next slide. Now, this is the slide which will make you understand how the stresses are generated and acting. Now, you see here the green lines, which is your compressive stress trajectories. We are not worried about this because concrete is good in compression and it will take care of it. But these yellow oranges color lines are the tensile stress trajectories which will go on increasing up to the point where the stresses become linear. Up to there you have this, the curvature effect which I told here. You can see this here, how the tensile stresses go on increasing with the change in curvature of the stress diagram. So these tensile stresses which are generated in this area are very dangerous for the concrete. Okay, so this is what we have to understand first. What is the end block? Okay, or what is the anchorage zone? What is its importance? Then we can easily understand why we are designing the reinforcement for that particular section. Okay, so this figure is also of high importance with respect to concept, as here we see how both tensile as well as compressive stresses are developed in the particular anchorage zone. Now next, the two terms which we will be deriving from here, which we will be using further in the calculations, are y naught and yp naught. So if you see here, this is y naught and this is your y naught. Okay, so both are the dimensions of the beam. This is the cross section shown. So this is the depth and this is the width. So which one we have to take when we discuss with the example, it will be more clear. And yp naught is the area where we are using to apply the pre-stress. Here there is a plate through which your pre-stressing wires will be pulled. Okay, the depth of it is nothing but yp naught. Okay, so two terms, y naught and yp naught, further they will be coming in the formula. So this view is telling us the importance of your anchorage zone, as we have both tensile as well as compressive stresses acting in this region at a time. Okay, acting in this region at a time. Hence, a proper reinforcement needs to be designed for this section. Now, with research, actually this research had started in 1945, 1950. Further, we are studying it in 2020. Okay, that's where we are. So, method of analysis, we have standard 4 methods. One is the Magnell's method. Sorry, 3 methods. One is Magnell, second is Guyon's method, third one is the Helsinki and Rowe method. It is not Helsinki, it is Helsinki. Don't relate it with your online series. Okay, so now the third method Indian code has adopted for forming the regulations. So basically we will be more concentrating on this third method or the Indian code method itself for solving the examples. Then the Indian codal provisions. The provisions of Indian standard code, that is IS 1343, for computing the bursting tensile force. Now what is the bursting tensile force? It is that excess tension which will be created in the anchorage zone or the end block, which will lead to the bursting of concrete. Okay, so that is the bursting tensile force. Okay, it is based on Helsinki and Rowe method and it is similar to the British code provisions. So it is given by the formula FBST. BST means bursting is equal to PK into bracket 0.32 minus 0.3 divided by y p naught upon y naught. So Pk is the jacking force and y p naught upon y naught is the distribution ratio. So as of now, you just note down this formula. Once we start with the examples and once we use the formula, you will understand its correct application. So in this module, we have started with the end block or anchorage block. The analysis examples, if you get in the final exam, they are quite relatively easy. Based on 1 or 2 formulas only, you have to find the bursting force and design a suitable reinforcement to overcome that bursting force, which is the main aim of this part of the module. So hope you have understood what is an anchorage zone, why is an anchorage zone critical zone or an important zone, how the stresses act in this zone, how the tension and compression is generated because of the change in curvature of the stresses, and then further Indian codal provision provides the formula which is given here for computing the bursting force. In the further lectures, we will go ahead with the discussion and solve some examples where these concepts we will be using. Hope all of you are fit, fine and healthy. Start studying seriously with respect to your final exams, and if you have not studied initially, you will have time where you have to sit back and go through the previous lectures, so that in future when you have to face the final exam, things won't go out of hand. Okay, so all the very best. Hope you keep yourself up to date. Thank you.